Okay, so this is a triangle we're using to prove the cosine rule. Now you understand that the triangle is formed based on the the dividing of the triangle into two. So we want to use these unknown values here and these unknown values here to be able to derive the cosine rule. So remember that the cosine rule can be in different forms depending on the part you're looking for. So basically, for this triangle, we are going to be using this cosine rule of b squared equal to a squared plus c squared is equal to minus 2ac cos b. So the cosine rule can be on different forms depending on the part you're looking for. So if it's a square you're looking for, that means that we're going to flip the triangle so that a will be on this side. There's a way you turn this whole triangle, so that we have a square for the cosine rule become a square equals to b square plus c square minus 2 bc cos a. And if you have to change it and turn it over to in a way that c is maybe on the side of b and then b, like there's a way we have to flip the triangle to be able to get this rule, because we have to use this type of triangle. There's also another type of triangle we can use, but for this one seems a little bit simpler, so that's why we're using it. So we have for c, if we have to look for c, we have c square is equal to b square, no, a square, sorry, a square plus b square minus 2ab cos c. Okay, so if you notice, they follow a pattern where the first part here is actually the Pythagoras theorem for each of the letters. Okay, now this other side is just an extension of this rule, the Pythagoras theorem. So this, and also you notice there's a pattern too for this other extension. That's where we have these two letters summing each other. They are in product form, and for 2 here and cos of this value here on this side of the angle of B. And then also the same thing here. If you notice, it forms a pattern. But there is a derivation for each of these, and we're going to be deriving just this one for today. But if you can derive these and derive these by flipping the triangle in a way to have each of the sides facing the other side. There's a way you can do that. Okay. So let's derive this. Let's derive this triangle, this cosine rule, this first one here. Okay. So this is what we need to take note of. Let me clean this. We have to start with the Pythagoras theorem using this triangle. So we have here b squared, which is the hypotenuse here, is equal to what? This is the opposite, and this is the remaining side. So we have this side first, c minus x. Now, how is it c minus x? I think I explained that, but well, I'll explain that again. So we have c minus x squared plus h squared, right? Okay. So how do we know is a c minus x? So it is due to the form from this c, this distance from a to b, minus this value here. This will give us this value. Let me just explain it this way. So if you have a triangle, and this is a, and this is b, and this is c, and you know that from here, a to b is, let's say, 5. And if you divide a triangle and you say that here is this side of the triangle, here is 3, how will you get this side? To get this side, you have to say this bigger side, which is from a to b, minus this side of the triangle to give you this side. Because the sum of these two sides here, let's call it p and q, will give you this 5. So that means this side has to be 5 minus 3, right? The same way it is c minus x, since we know that this side is x. So it is c minus x, which is this whole length. Okay? So that means here, the answer here will be 2. P will be 2. So let me just clean this out. and throw it back. And that means 5 minus 3 will give us 2, because the sum of these two sides will give you this. Okay? Alright, so since we've explained this, if you do not still understand it, you can ask questions on that, and then we'll explain it very well for you. So let us expand this. Okay, since we've understood that, if we expand that, we have, you should know how to expand this, right? So we'll have c squared minus 2cx plus x squared, okay? Then plus h squared. So this is when you expand this is what you get, okay? I'm sure you understand that. Okay, so now we've gotten that. Now we need to know that this x squared plus h squared actually means something. If you look at this triangle here, this other triangle, this other side here, you see that a square, that is this hypotenuse, a square, that is, if you put the Pythagoras theorem of this triangle, you have a square is equal to what? X square plus h square, right? So this other triangle is also useful, and that is what we're using now. So instead of leaving it as just x squared plus h squared, we're going to replace this x squared plus h squared with what? A squared, because we've used the Pythagoras theorem on this other triangle to know what x squared plus h squared is. You understand that? Okay. So we want to replace that now. Sure you understand that when we replace it, so that you wouldn't say this is strange. So this will now give us b squared is equal to c squared minus 2cx plus a squared. And you understand how we got the a squared, because a squared in the other triangle is x squared plus h squared. Okay? Now let's rearrange it. Let's make it a little bit neater. Let's move to another page. If we rearrange it, we will have b squared is equal to a squared plus c squared minus 2cx. Okay? So we're almost there. Now, let us look at the triangle again and understand something, that x actually also means something. This x here on this side needs another color to be able to represent this well. So this is x here. Okay, now this is a triangle that x is working on, and this is an angle for b here. Okay, now the angle for b, if you use cos, since we're dealing with cosine rule, the cos of b is adjacent over hypotenuse, right? So, and we know that the adjacent here is x, because there's also an angle here. So this is x, and the hypotenuse here is a, right? So we can just say that, let me put a line here, that cos b from that triangle, which is adjacent of a hypotenuse, is what? Is x over a. You understand that, right? And if you cross multiply, you see that x is actually equal to what? A cos b. You see that, right? Now, if you replace this x put it into this point here, this actually will now change the whole equation to look something like this. 2b squared is equal to a squared plus c squared minus 2c for the value of x, which is this, a cos b. Okay? Now, if you multiply through, you see that b squared is equal to a squared plus c squared minus 2ac cos b. Now, this exactly you see here is the cosine rule for b squared. The cosine rule is used when you have two sides of a triangle and an included angle. I've given examples on how you can work on the cosine rule in a bearing under the topic of bearing. So I think you should check that out and see. Now, we have also explained that if you want to find, there's a cosine application for a square, and there's also a cosine application for c. So I think I mentioned that in the beginning of the video, but please, if you have any question on how to find the cosine rule, you can ask. But this exactly explains everything. Just understand that this is a triangle we are using to find the cosine rule. Thank you very much.